So for this experiment, we're going to have to calculate something that's not measurable. So if we look at this, like we're going to kind of start backwards and we can't measure this. So we're going to calculate it. So we're going to go ahead and put in here that we've got some foil and we want to know its height in centimeters. So if we kind of think back to what we learned, well, we learned in our experiment that there were a certain number of grams, I think it was 2.48 grams of aluminum. So for every 2.48 grams of aluminum, there is 1 centimeter cubed of aluminum. So if we think about that, if we knew the mass over here, if we knew the mass of aluminum, we'd be able to solve for the volume of aluminum. So we will be able to calculate here the volume, the volume of aluminum in centimeters cubed, but only if we measure its mass. Okay? From that volume, we know that this is a regularly shaped object. If we cut it out, it could be length times width times height. And if we knew the volume, because we're solving for it here, and we can measure the length and the width, we can solve for the height. So again, these are measurable things if we cut them out to be measurable. So here's our height, or our length in centimeters, and our width in centimeters. And from that, we can calculate the height over here, and the volume is something that we can get from here. So I think that's everything we need. Now we just got to go back up and design a procedure to solve for all of these things over here. So we're going to have to figure out how much foil we're going to use, and we probably want to use a variety. So we're going to cut maybe a 5 centimeter by 5 centimeter piece of aluminum, 10 centimeter by 10 centimeter piece of aluminum, and a 15 by 15 centimeter piece of aluminum. And we're going to measure the length and width of each. We probably have to add in foil 1, foil 2, and foil 3. And then from that, we could mass each piece. And that'll get us, believe it or not, that gets us all of the measurements that we need in order to calculate, down here the height, because we'll have the mass here, and we can use that ratio. We know that the graph for this, we graphed in class, looked like this. So when we had the volume against the mass, it was what we call a direct linear relationship. So let's say that this was 1 gram, that would mean that we'd be dividing by 2.48, which would mean we'd have a fraction of that original mass. Hope that helps. You kind of think this through.